Hi, everyone. We are broadcasting live from the Delta Lake. Welcome to Delta Lake Community Office Hours. This will be our last office hours for 2022. We love seeing people joining from across the world since we have global community. So please let us know where you are joining from, and we would be happy to see where our audience is from. Myself, I am in San Francisco. Florian, how about you?
I am in Bordeaux, in France.
Oh, cool. Bill?
I'm in very chilly New York right now.
Very chill. Yes, I hope you get like white Christmas this time.
Yeah,
Or
so far just freezing temps. That's all. That's the only Christmas present I have. So.
Awesome. All right. So let's get started. Today we have a special edition of Office Hours, and in today's session, we are doing a time travel of our Delta Lake project in 2022. Joining me today are the two other long-term Delta Lake contributors, Florian from Back Market and Will from Databricks. So why don't I let them introduce themselves? Florian, do you want to go first?
Yes, thank you, Winnie. So I am Florian Ballet. I'm working at Back Market. And right now I'm a staff data engineer. I'm working with the Data Tribe on many topics. And I'm also a contributor to the Delta RS project.
Awesome. That's great. Will?
Yeah, sure. Hi, everyone. My name is Will Girton. I'm a senior specialist solutions architect at Databricks. Been with the company for about 4 years. I'm an open source Delta sharing committer and evangelist. I'm happy to speak with you all today.
Thank you, Will. This is super exciting. I get joined by Florian and Will. So, and myself, I'm Vinny Jaiswal, developer advocate at Databricks. I have been a part of Delta Lake project since its inception, and I love bringing the community together and work on some of the advocacy efforts for the project. I have helped a lot of Databricks customers build their pipelines on Apache Spark, Delta Lake, and other projects. So very happy to be here. In today's AMA session, we will provide the project highlights, and we also want to keep our regular format, which is answering your questions. And we also want to know what are your big ideas for the project for 2023. So add your questions on our LinkedIn Live and other sources where you are joining from. We will look at your questions and answer them as we go through our session today. So for those who are new to the project, let's start with what Delta Lake is. Delta Lake is an open source project that enables building a lakehouse architecture on top of your existing storage systems like S3, ADLS, TCS, HDFS. And it offers many key features, including time travel, ACID transactions, scalable metadata, and more, which are required for making our data engineering dreams come true. And with compute engines, including Flink, Hive, Kafka, Presto, Spark, Trino, etc., and APIs like Scala, Java, Rust, Ruby, and Python, Delta Lake enables building the lakehouse architecture on any platform and any environment. And for those who don't know how Delta Lake is being used, it's actually used to solve a lot of challenges, some of which are around malformed data ingestion, difficulties deleting data and compliance, or issues modifying data for data capture. Your data can be from like multiple different variety of sources, and it is either getting ingested either as a batch or maybe like, real-time stream processing. And on my screen, I'm showing you the end-to-end architecture, which is a lakehouse architecture that allows users to run like a lot of data and AI applications, and your data needs to exist only once, and you can run like a lot of different use cases on it. And to learn more about the project, definitely we have a website, we have GitHub, so head over to delta.io to learn more. With that, I want to quickly take you through a journey of highlights and pace of innovation. So you can see that this is the release highlights and how fast the pace of innovation has been within 3 years. Today, we are at Delta Lake 2.2, and it's been a long journey to get there. The slide is packed with features, so you can actually see what I'm talking about. So bear with me as we take a quick look back at where we have been and figure out how we all got here. Delta Lake was first open sourced in April of 2019, and that was the first version, which was pretty exciting. It included asset transaction and schema management. It included streaming and batch, but we didn't stop there. We quickly added support for DML, commands and vacuuming. We added Scala and Python APIs. Next, we improved compaction and concurrency. It was made possible to convert Parquet tables into Delta using SQL only. Other things that were added in the next version are things like describe history, which lets you understand how your table has been evolving over the period of time. In 0.7, we added the support for a whole bunch of different engines like Presto, Athena, and then in version 0.8, a lot of work went into adding merge and other features like parallel delete and vacuum. Soon enough, we released the version 1.0 in May 2021 with features like generated columns, multi-cluster writes. This was a very big release as it included a lot of these features as well as cloud independence, which made Delta run everywhere. So that was pretty exciting. And then it was impressive to see more and more community contributions, which led us to quickly release features like Delta Standalone. And that again was a very big release because it unlocked a whole new possibility for our other ecosystem projects to work with Delta Lake. And soon Delta Lake connectors like Apache Flink, Presto, Apache Pulsar were released towards the end of the last year. Users of Delta Lake wanted more performance and functional features, and the community heard. So we actually focused on releasing features like optimized data skipping, S3 multi-cluster writes, column renaming, among others, in the first quarter of this year. Flashback to our Data and AI Summit in June 2022, Delta Lake actually announced the version 2.0. This milestone version enabled our community to benefit from all the Delta Lake innovations, with Delta Lake APIs being open sourced. So the wider Delta community collaborated to add features like optimize the order, data skipping using column stat, S3 multi-cluster writes, change data feed, connectors for Chino, and more. These features dramatically improved data engineering performance and manageability compared to previous versions that we had released. And then we added 2 more releases recently, version 2.1, which includes support for Apache 3.3, streaming feature like trigger available now, describe detail in Scala and Python APIs, running operation metrics from SQL. And recently, literally last week, we released version 2.2, which has lots of query features like improving the performance of queries containing limit clauses, and significant reduction in query time for aggregate queries because they now just needs to read the table meta. We also added support for collecting file level statistics as a part of column to convert to Delta command, and we have made significant improvements in metrics and monitoring and so on. And the project is continuously adding more connectors. Its commitment to support wide variety of ecosystem companies makes it easy to build ETL pipelines with various technologies. Okay, that was a lot of features. And the pace of innovation in Delta Lake project has now made it one of the most widely used lakehouse format in the world. In 2022, Delta Lake monthly downloads skyrocketed from 685,000 to over 10.5 million in monthly downloads. Completing this work to open source, you saw, right? A lot of Delta Lake features, while tens of thousands of organizations are running in production, was no small feat. And due to this activity and growth in unique contributions, the Delta Lake project logged an astounding 633% increase in contributor strength over the last 3 years. Now we have more than 218 contributors in Delta Lake, and a lot of Delta Lake is powering a lot of production use cases. So kudos to the Delta Lake community and its many, many contributors for making this possible. These are just some of the logos that I'm highlighting here. There have been like many more people working from different organizations. So I'll pause there. This actually perfectly leads us to our next segue because we have two awesome contributors here, Florian and Will, who are going to provide highlights into two other sub-projects, which is Delta Rust and Delta Sharing. So let me see if there are any questions. There's a question, I want to clone a Delta table with Delta logs for disaster recovery. Deep clone will be helpful. Yes, that is, and we actually know about it. We are working on, making that clone available in 2023. So please stay tuned, Manikanan. Thank you for bringing that up. Yeah, and please definitely ping your questions on our chat. We will be happy to take those questions. So I will go next, Florian.
Yes, thank you, Vinny. So I'm here to talk about Delta Rust. So you can move to the next slide. Thanks. So Delta Rust is a native Rust library for Delta Lake, which provides bindings into Python and Ruby for the moment. This library provides low access to Delta table in Rust, which is the core, and it can also be used with different data processing solutions, for instance, Polar or AWS SDK Panda. So just to sum up the different points, Delta Rust is pretty useful when you need to access to Delta tables without having to spin up a new Spark cluster. So you have the part of the Rust core, which have different layers, but we used many different dependencies, Tokyo, Object Store, Parquet, and Arrow, and we create a binding with Python using Maturin and the other library dependency in Python. So if you would like to use Python with Delta Rust, you just have to pip install Delta Lake from PyPy. And if you want to use Rust, you can use cargo install Delta Lake to have only the crate. We use Object Store to have a good way of accessing Delta tables in the cloud provider. So you can access to the local disk, but you can also access to S3 or cloud storage for GCP, for instance. So you have everything into the GitHub repository page, but you can also find the Python package inside PyPy in Delta Lake and on the crate.io for the Delta Lake Rust. We can move to the next slide. So for this year, many releases, 10, I think. We have a major one with Rust 0.5, and we also publish a lot of different releases in Python. We can separate the release between the Rust crate and the Python package. We deploy many things into Python because we fix a lot of issues, and we would like to be really fast on this one to make sure that everyone could use Delta Lake Python package. On the feature side, we improve the protocol support for reading operations. It means that we collect more metadata inside the transaction log. If I take one example, it will be to access to the statistic written into the transaction log to make it available in Delta Rest too. We unify and improve the object storage service support because it was not the case before. We rely on many different crates to do so, but we use right now Object Store, which is a good way for managing different object storage services. We have the first experimental writer at the moment. It's still experimental, but we are working intensively on it to make it production ready. We support the optimized command, which was not the case before. So it was introduced this year and it was a huge improvement. And we are also revamping a bit the integration between Python and Arrow by using PyArrow and to make things more Python and Rust closer when we deal with a lot of different calls. And also we are integrated in many different repositories. Just to name a few, we have Polar, AWS SDK Panda. We also have an integration with Data Fusion, Dask, DuckDB. So we are working on integrating Delta ARS in different parts of the data tools. And for the start part, more than 700 stars right now. So it's really a huge improvement. It was 300 last year. We have more than 600 pull request merge, a lot of forks, and we reach also 1 million download on the PyPy. So it was a huge improvement on the way Delta RS is used right now.
That's super cool.
So we can move to the next slide. I would like to take the time now to thank all the contributors, and I would like to give a special shout out to Will Jones and Robert Park that did a great job in Data RS by improving the Rust rate, but also the Python binding. Thank you. It was really an incredible achievement, and a lot of contributors that joined the community and build with us. So right now we are more than 60 contributors. So I would like to thank you everyone, because it was a great improvement, and we can wait for the next year to improve Delta RS.
Wow, that was like a lot of work, Florian. And I know that yourself has contributed a lot. So thank you so much. I think we are seeing a lot of momentum in Rust because of active contributors like you. So thank you for making those lives easier for Delta and Rust users. Awesome. For everybody who joined, please do ping your questions live in our LinkedIn comment, and we will be taking the questions. Next up, we have Will, who is going to share updates on data sharing. So take it away, Will.
Yeah, awesome. Thank you, Vinny. So another great project under the Delta Lake ecosystem that I think has the potential for a major impact is Delta sharing. So I'd like to talk a little bit about Delta sharing, kind of a recap of what has happened in the past year. And then also go over another shout out to some of our contributors. I'm going to take your questions at the end, of course. So the way that I always describe anything is I like to start with a problem that's being solved here. And the problem that Delta sharing objectively tries to solve here is that you might have a data set and you might transform it, you might clean it up, maybe add some derived columns, or even add predictions to your data set. And then you might need to share that data set, whether it's within your organization or maybe across your organization, even across database accounts, for example. So one way that you might do that today is to leverage the native cloud controls. And let's face it, nobody wants to, at the end of the day, fiddle around with IAM policies. It's difficult. It's hard to get securities approval. It's error prone. It's just not a scalable solution. And that's really what Delta Sharing Project aims to solve here, is to simplify sharing your data sets, whether it's in your organization, say from data engineering team to your data science team, or maybe across your organizations, maybe you sell a data set for a premium. And what Delta Sharing does is it defines an open protocol for sharing data sets and exchanging data sets in real time securely. And the data architecture is very, very simple. So it really is comprised of two parts. One is the data provider part. And what the data provider does is the data provider will basically expose one or more data sets through what we call a sharing server. And then the second part of the architecture is the data recipient. That data recipient can, through a sharing profile, a very small JSON file that has an endpoint and credentials for accessing this data set, they'll simply just choose whatever connector that they want to use for their programming language or application, load up the sharing profile, and then they can immediately connect to these data sets and immediately start using them. And then lastly, the one thing that I think is really cool about the Delta Sharing project is that none of that data traverses through the data sharing server at all. Instead, that data sharing server is really responsible for compiling a list of pre-signed URLs, file URLs, and then your data client, the data recipient can then use the client to load those data files into their application. So again, none of that data flows to that data sharing server. So it's a very, very scalable architecture. And then last but not least, there's an ever-growing list of connectors. So if you wanted to go to the next slide, I'll touch a little bit on that, some of the key milestones over the past year. So over the 2022, we've the Delta Sharing project has released over 5 new releases. And there have been a lot of major features that have been added into there. Some of my most favorite features that have been added are Spark streaming support, time travel, change data feed, support for Google Cloud Storage, and then also additional APIs for querying things about your share metadata, your table version, all the metadata about your data sets that you're sharing. And then last but not least, there's also increase from demand for downloading the product as well. We've seen over 500,000 unique downloads across PyPy and Maven. So it's an ever-growing community. And then if you want to go to the very last slide, the one thing I like to touch on is just how much of an impact that has happened over the past year. I counted it up this morning. We have over 10 new connectors that have been added. There's one that's currently pending. So in this past year, we initially started with just Python and Apache Spark connectors, but we've also added 10 new connectors from Java, MLflow, Node.js, Go, Power BI, Excel, R. These are all really good connectors. So it gives you, as a data recipient or a data provider, kind of the ability to share your data sets across a number of consumers in a format or a language that's convenient for them. So there have been a ton of contributors. There were actually too many to list here, but just wanted to give a quick shout out. It's super impressive to me at the number of connectors we've added.
Wow, that's super
cool.
awesome, Will. With that, there is one question. This is super awesome, by the way. There are so many connectors, so many PRs that has been raised and actually closed with all these projects. There's one question around, I am trying to create a near real-time Delta Lake for my application. One of my data sources is implemented as near real-time Delta Lake. Would it be possible for me to use Delta sharing to stream those changes from a CDF into my Spark stream and then into Delta Lake?
You can. Yeah, with the latest release 0.6.0, it now provides support for Spark streaming. So you could absolutely do that.
Awesome. Florian, there's a question for you. Is there an easy way of transforming an arrow schema into a delta schema in Rust?
I think it's a good question because right now I think there is one, but we need to check and go into the details to have the solution.
Got it. Didn't we release like a PyArrow integration, Florian?
It was a change during this year. We transformed the arrow schema in the Rust binding. It was not the case before because we tried to translate it on the Python side. But right now, everything is done in Rust, and the binding with PyArrow is also supported in Rust.
Got it. Awesome. There's a question on delta sharing. Is there a limit on how big of a delta table we can share?
Yeah, so that really goes back to that architecture concept where I was talking about. So none of that data actually traverses through that delta sharing server. So you don't need to really worry about scaling that too much. Mm-hmm. Instead, there is no limit per se to the size of the delta table that you could share. It really comes down to the client that's reading the data, because that delta sharing server just gives that client, the data recipient, a list of files for their application or their client to basically load into memory or save the data. So ultimately, it's up to that client what they're capable of reading. If it's a super huge table, then it kind of makes sense to add in things like limits. But ultimately, no, there is no limit to the size of delta table you can share.
Got it. Awesome. Florian, there's a question on Pandas data frame from AWS S3. Was there any work that was being done there this year?
A lot of improvements were done to use, for instance, the profile or some configuration to access to S3 in different ways. It was not the case before because we were relying only on the environment variable for the access key or the secret key. Right now, you can use profile. You can use different parameters to make the connection between Delta Rust and the S3 Delta tables.
Got it. Got it. And then there is a question on what are other integrations that are coming up in Delta Rust project?
Oh, it's a, a wide question because I think we can use Delta RS in many different other tools. The last one was regarding Panda integration with AWS SDK, to make sure that we can have an access on the Delta table using a small runtime with a Lambda on AWS. So it was a huge milestone for us. The next one has been Polar RS on the Rust side. Maybe the next one will be another tool. We don't have any clue right now about the next integration, but we would like to improve the Python binding into different data tools processing. So if you have any idea, don't hesitate to submit an issue for having a new feature request about one topic.
Yeah, exactly. Yeah, for any projects, for that matter. Will, there's another question. So for Delta sharing to happen, what are some of the security aspects that Delta sharing protocol takes care of? For example, if I have like different systems, I'm logging into AWS, that's where I have my tables, but that they are not in Delta Lake, some other format, and I have to connect to Delta Lake. Does it integrate with AWS security? How does that work?
Yeah, sure. So that's kind of part of the problem that's kind of shifted away from the data recipient. Previously, if you were, or even today, if you were to use cloud native controls, your data recipient or data team that needs to access that shared data set has to worry about all the different cloud security protocols. Ultimately, that kind of maintenance is shifted into the data provider. So it's a one-time setup essentially, and you're essentially giving trust to that sharing server to assume a role or an identity to pre-sign all of those data files with basically an expiration, a short-lived URL so that data recipient can read the data temporarily. So as a data recipient, you don't really need to be too concerned about the different cloud protocols, security protocols. In fact, you're totally abstracted from it. You might be joining two tables together from, say, AWS S3 and then Google Cloud Storage, and you would never even know. Ultimately, the provider would take care of setting up the appropriate credentials across the data sets. And then there's simply just a default access key token authentication that takes place between the data recipient and the sharing server. And of course, you can increase that as well. You can put an API gateway. We have a great blog that just came out into the Delta website that details that. So if you're curious about that, I definitely give that one a read. But ultimately, as a data recipient, that burden is shifted into the data provider, basically.
Awesome. That's great. There's another question on, I ran vacuum command and it ran successfully. How can I see what version it has created in our Delta table? So I think every transaction that you do with Delta Lake, either you update just one row, one record, or even like perform deletes, it should create a new version new version entry into your log file. And to actually view all those details, you can use describe detail command, and it should allow you to see the time changes, the operation metrics, and all of those commands. And I think there are other question about like if I delete, the table doesn't get deleted immediately. So in that regards, what Delta Lake does is it allows you to time travel in case if that delete was accidental, and that way it saves you like a burden of losing some records. So it whenever you perform a delete, it actually does a soft retention of those records for 7 days, and after 7 days it automatically deletes it. However, if you do want to immediately perform the delete action and have it remove all those files, you can actually specify the retention duration, and retention can be 0 hours, for example. Hope that helps. Awesome. Will, would you provide us what else are you working on? What are some features that you will be working on in 2023?
Some additional connectors or features.
Nice.
Yeah. So I can't. I'd love to spill the beans, but then. So I'll give you a little bit of insight. So currently today, the Delta sharing protocol only allows you to share Delta Lake tables, but there's a possibility that protocol might expand in the near future. Another one that I think I'm really excited about, or just some more connectors that are being added to the ecosystem. Again, nothing set in stone here. It really is ultimately up to the community to provide that demand, and we kind of shift development that way. But I'm really excited, I think, for an upcoming Trino connector, as well as Looker as well.
But what will that do, Bill? Don't we have Trino connector already in Delta Lake ecosystem?
So we do. So there is a Delta Lake connector for Trino. However, this connector is a little bit different in that it will understand the Delta sharing protocol.
Got it. That's awesome.
Yeah.
Awesome sauce. That's exciting. And since we got a lot of questions around, what is coming next. We are not done here, and let me also quickly go back to my screen share. We are working on like a huge roadmap, and of course, definitely we are not done. The community is constantly working on the new features. So if you want to have a voice, if you do want to contribute, please do head over to our GitHub and start contributing. There are some cool things which are coming up, like clones, iceberg to Delta connector, identity columns, things like that. And these are the ways to engage. You can actually go to our Delta Lake Slack channel, Delta Lake GitHub, YouTube channel, Google group, and several others. Start with good first issues. We have several issues that are identified. Start with that. If you don't feel comfortable, head over to Slack channel and start asking questions if you are stuck anywhere. Then we also have like a lot of issues which community actively talks about. Participate in those discussions. If you have idea or if you have a code that you have made work in your own environment, you can contribute that. And you create a pull request. So I would be excited, and we would love to see more contributions from one of you. So let's see, what we get from you all. So that was all. Any other closing comments from anyone? Cool. Can't wait to see what's coming in 2023. Thank you. Yes, I'm super excited too. Great. All right. So thank you so much, Florian and Will, for joining us. And thank you all who asked questions and helping us run this event. 2022 was super awesome as we saw it. And we definitely are going to bring more excitement in 2023. So thank you all. Bye.
Thanks all.
Thank you.